Hello, E-class. Today we're going to learn about solving for a variable. But you might say, Mr. Coles, we've already solved for variables. We understand that. But I'm going to say, hey, I'm going to throw you a curveball here. This time we're going to use formulas. Formulas are equations that contain rules amongst relationships for quantities. But sometimes those quantities are unknown. And in a formula where the quantity is unknown, we just use variables or letters to represent them. In this formula, d, or distance, has been isolated. But let's say, for sake of argument, that I actually wanted to isolate r instead. Let's say that I didn't know what the rate was, but I did know what the time was, and I did know what the distance was. So having d isolated doesn't help me. I need to have r isolated. I need a strategy to do that. Here's a strategy. Locate the variable you are asked to solve in the equation. Well, that's good. I want to isolate r instead of d. Identify the operations on this variable and the order in which they are applied. Well, there's only one operation on r. It's being multiplied times t. And then use the inverse, or opposite, as we've called it in class, the opposite operation to undo the operations, to isolate the variable. Well, the opposite of multiplying times t is multiplying times 1 over t. So now let's go ahead and do this. On this page, I'm going to tell you that my distance is equal to 20 miles. And let's say that my rate, I don't know the rate, and that the time that it takes me to run that 20 miles is 4 hours. So I want to know the rate at which I was running. Well, I'm going to multiply both sides times the opposite of t, which is 1 over t. I'm going to do that to both sides. 1 over t times d is d over t. On the right side, the t's are going to cancel out. It just leaves me with r. So my rate is equal to distance over time. Now that I know the distance is 20, I'll substitute that in. And now that I know the time is 4 hours, I'll substitute that in. And this comes out to 20 divided by 4, which is 5 miles per hour. Not a bad pace. So that's how I would solve it. I'm isolating the variable and rearranging. Now let's look at this conversion equation on the right. Conversion of Celsius into Fahrenheit. So if I know the Celsius, if I know it, then I can figure out the same measurement in Fahrenheit degrees. But let's say the opposite is true. Let's say I don't know Celsius, but I do know Fahrenheit. So that means I need to solve for Celsius. For the sake of argument, let's say that it is 59 degrees outside, which is a nice, cool temperature. 59 degrees. I'm going to apply that at the end. First, I'm going to solve for my Celsius. To do that, I need to see that it's being multiplied times 9/5, so there's my coefficient, and then I'm adding 32. So the first thing I need to do is to get rid of that 32 by adding a negative 32 to both sides. That's going to cancel the 32 out. On the left side, f plus a negative 32 is the same as f minus 32. I can't do it because I haven't substituted my value for f yet. So I'm just going to write f minus 32 because that's what's happening. And then you still have the 9/5 c. To undo the 9/5 c, I'm going to multiply by the reciprocal of the coefficient, 5/9. But I need to do that on both sides. I'm going to give myself a little more space here. I need to do that on both sides. So I'm going to do that on the left side as well, but I need to multiply 5/9 times the whole thing, so I put it in parentheses. Now, on the right side, they all cancel out. That's what I want, and I'm left with c. On the left side, then I have what I already have written, 5/9 times f plus a negative 32. To figure out what Celsius is, I substitute in my value of 59 degrees. Oh, I'm going to do that back in blue. Plus a negative 32. And this is going to wrap up nicely. So again, 5/9 plus a negative 59 minus 32 is 27. Well, 9 goes into 27 3 times, so this is actually 5 times 3, which is 15 degrees Celsius. So 59 degrees Fahrenheit is 15 degrees Celsius. But the reason I was able to figure that out is because I rearranged my equation and solved for a different variable. So this should be pretty obvious now. What I want you to do is read this short sentence or paragraph and solve for the variable I. It's pretty simple to do, actually. I just want you to practice. And then these two. Explain how to solve P for W. So that's the equation for perimeter. And I want you to solve it for width. and then you just show me the steps. And then the last one, solve for t in that expression as well. So you're just going to rearrange these to solve for the different variable. Do those in your journal, bring them to class.